Yeah, so there's another type of distribution of chi-square. But before we do chi-square, let's do that question. That is April 2022. Question 3. I want us to do the entire question 3 with 20 marks. It's all about hypothesis testing. Part 3, a random sample of 350 invoice. So N is 350. N is 350. So that means use the Z test. A random sample of 350 invoice issued by RX Limited revealed an average invoice value of 38,780 average. That's the mean of a known population, that 8,780, with a standard deviation of 8,750. 8,750. Now, this one is not a two-mean sample. This is just one sample. Required. The interval within. When you talk about the interval, this is not hypothesis testing. What is that? What is that? That's the confidence interval. The interval within which the population mean should fall at 95% of confidence. So that means the significance level, if you want to be 95% confident, the significance level will be 5%. And this is the confidence interval. When you talk about the interval, it's all about the confidence interval. So how do we get that? So it's X bar plus or minus Z standard deviation square root of N. We have X bar, which is that 8,750 plus or minus Z. We see that for confidence interval, we always use a two-tailed test. If it's a two-tailed test and we're using Z, and significance level is 5%, Z will be how much? 1.96. Good. You make a fingertips. Whenever you see a two-tailed test and you're using Z test at 5%, Z will be 1.96. Then you multiply by the standard deviation. Standard deviation is 8,750 square root of N. So our N is 350. So it will be that 8,750 plus or minus. Now give me the margin of error. That's what we call the margin of error. Sorry? Sorry? 116, right? 916? Like that, eh? 0.7. That's 1.7. So now give me the upper control limit and lower control limit. That is 750, you add 917, and you get that 667, right? When you minus, you get the lower control limit, you get 36, that 7. Exactly. So that's the interval. So that means the confidence interval will lie between 37,833 and that 9,667. Now let me remind you, for those who don't know how to get 1.96. And a normal distribution, the probability is 0.5. This is 0.5. For two-tailed test, we see that this one will be alpha over 2. Our significance level is 5%. So that means it will be 5 divided by 2 to get 2.5%. So that means the probability of rejecting is one which is 2.5%. What about the probability of accepting? So Z, we see that all this is 0.5. You eliminate the probability of rejection, which you are given is 2.5%, 0.025, and you get 0.475. Now, this is the probability, is not Z, is the probability. Now, how can you use the probability to get Z? So we use Z table. This one you read it inside the table, not from the table, but inside the table. So that means go to that table, huku ndani utafute 0.475. Now, once you get 0.475, you root the coordinates. So you get it's 1.9. There we have 6. So that's how we get that. Number 2 of the question, A part 2. The sample size of the invoices that would result in a 99% confidence of the interval obtained in A1 above. The sample size. So we want N so that we can be 99% confidence. If you want to be 99% confidence, now listen up here. That means all this is 99%. So that means the margin of error will be 1%. And these are two tail tests. Being 1%, it will be alpha over 2. So this one will be 0.5%. Also, this one will be 0.5%. And we know very well that the probability of this is 0.5. So now we need the probability of accepting. So it will take 0.5. We eliminate the probability of rejecting, which is 0.5%. It is 0.005. So give me the probability of acceptance. 0.495. Then read it inside the table. And it's not a must you get 0.495. You look at the figure close to that. At the figure close to that. What are you getting? 2.58. Correct. So our Z, now this is our Z. I want you to understand the question, because I'm sure you haven't understood the question. You're understanding what I'm doing, but you have not understood the question. Now, what was the question? Or what do we need? You are told that the sample size, that's N, of invoice that would result to a 99% confidence of interval. So what we need, how do we get the margin of error? Margin of error, this is what we are computing here. It's Z standard deviation square root of N. And of which we already have this. This is what we computed here, which is 917. So what we need is this N. So Z, we have computed Z at 99% confidence interval. Z will change. Now Z will be 2.58. Standard deviation does not change. Standard deviation need to be 87.50. You divide by the square root of N. Now this is what we need, the sample size. And the margin of error will be 917. So what do? Hey, this is simple mathematics. What do you do from there? So you cross multiply. You multiply by? Yes? You multiply by the square root of N. You multiply by the square root of N. So that and that will go. So now give me 2.58 times 8750. You get? 575 is equals to 917 square root of N. Then you divide both sides by 917. So give me square root of N will be equals to, sorry, 24.6. We need N, not square root of N. So what do? You square. Good. So you square. 606. As simple as that. For us to be 99% confidence interval, you must have a big sample size of 606. Number B of the question. Number B, you can do it as an assignment. It's very simple. The following information related to the operating life of two brands of mobile phones, brand A, brand B. Up to that, that's a 2 mean sample size. We have the mean life, that's X bar, standard deviation, sample size. Look at the sample size. Z or t-test? Z, good, required. Advise a potential customer on where there is any significant difference between the quality of the two brands of mobile phone at 5% significance level. So null hypothesis, mean of 1 is equal to mean of 2. Alternate, brand A quality is not equal to brand 2 quality. Significance level is at 5%. Z statistics, X bar 1 minus X bar 2. Standard deviation of 1 square, N of 1. Standard deviation of 2 square, N of 2. X bar 1, we have the mean. The mean we have is 1730. Minus brand B, 1684. Square root of standard deviation of 1, we have is 102 square. N is 200. The other one is 108 square over 200. Give me that. What are you getting? Sorry? 4.38. Now, this is Z test at 5%. How much was it? Good. 1.96. 1.96. Our Z calculated is 4.38. Does it lie in between the acceptance region or rejection region? We do what? We reject null hypothesis at 5% significance level. But here you are to advise this customer. You see, in this case, this is the actual application of hypothesis testing. Now you are trying to compare the quality of the two brands, brand A and brand B. So in this case, you are testing whether the two are the same. Can you read the question again? Advise the potential customer on whether there is any significant difference between the quality of the two brands of mobile phone at 5%. We want to be 95% sure. Now, here you have rejected the null hypothesis. You see, null was saying that quality A and quality B are the same. But in this case, you have rejected the null hypothesis. If you reject null, you accept alternate. That means brand A and brand B quality are not the same. So how do you advise? The brand quality are not the same. Are not the same. Good. So, part C of the question. Part C of the question. A certain new, but first of all, you can copy. You can copy. So now let's do chi-square. I had mentioned chi-square is one of the distribution techniques, Z-test, T-test, chi-square, so that chi-square is used to compare the attributes. I remember giving you this formula. So I want us to do that question. That the chi-square are used to compare the attributes. How do we evaluate that? So this formula of determining the chi-square, you take the summations of O is the observed variation, E is the expected variation. Where how do we get the expected variation? You take the column total, you multiply by the row total, you divide by the grad total. And to get the degrees of freedom, because chi-square, you have to use the chi-square table, you take the number of rows minus 1, you multiply by the number of columns minus 1. So I want us to do an illustration. April 2022, question 3C. Hoping you're there, and we're told that a certain new strategy, K, was claimed to be effective for teams playing a certain game. In a marathon of 400 games, half of the team used strategy K and the other half used strategy P. The team performance was recorded in the following table. So we have that table. For those who adopted strategy K and for those adopted strategy P, we have those won, defeated, or drawn. Required. On the basis of the above data and using the chi-square method, advise whether there is a significant difference in the effect of the two strategies, K and P. So now the formulation for chi-square is always the same. Null hypothesis, we always say that there is no association between strategies. Then alternate, there is an association between the strategies. Then the significance level. Now, whenever they are cited, always use at 5%. In case you are told to conduct a hypothesis testing and there are silence about the significance level, the recommended and the standardized is at 5%. So how do we come up with that? So you come up with a table like this. Because we need to determine the expected. So here we have the strategy. And strategy, we had strategy K, P, and then we get the total. Then we also have the status. We have those who won, defeated, or drawn. And then we get the totals. So here we have the observed, that's O, and here you have the expected. That's it. So for observed, here we had 130. Here we had 20. Here we had 60. We had 110. We had 30. We had 50. Now give me the total. Give me the total. Now give me the grad total. Then now let's compute the expected. And how do we get the expected? Now we said that to get the expected, you'll take column total, you multiply by the row total, you divide it by the grad total. This is what I mean. For example, to get this, you take the row total over column total, you divide by the grad total. This is what you'll do. You'll take 210 times 240, you divide by the grad total. So give me that. Let's round off. Sorry? 126. What about this? Now for this, you'll take 210, you multiply by 50, you divide by the grad total of 400. Sorry? To get this, you take the column total, which is 210, column total 110 over grad total of 400. What do you get? Sorry? 58. Do the same here. Yes? 114. $24. Yes? We have 52. Good. So now we can get our chi-square. To get the chi-square, we say that you take the observed variation minus expected. So observed minus expected will be 130 minus expected 120. Then you square, you divide by the expected. So expected is 126 plus, you need to sum all of them. Then you take the other one, it will be 20 minus 26 square over 26. 60 minus 58 square over 58 plus 114, sorry, not 114, but 110. 110 minus 114 square over 114, 30 minus 24 square divided by 24, and then here you have 50 minus 52 square over 52. Now let's do one by one. Aya. Yes. 1-3, good. I hope others are doing the second one, or the third one, or the fourth one. $1.38. This is 2 square. 4 over 58, you get how much? 0.07. That's 4. 4 square, that's 16. 16 of 114, what do you get? Hesabu ya haraka haraka. Unapata ngapi? 0.4. 6 square, that's 6 over 24, you get 1 point. Yes? 1.5. Then you take 4. 4 over 52, you get how much? Sorry? 0.08. Then you add all of them. This means summation. So can you add the total? Add the total. You get 3.3. Now we need to make a decision. So how do you make a decision? Now, when making a decision on this case, you need the degrees of freedom. And you see that degrees of freedom for chi-square, you take the row total minus 1, column total minus 1. Row, how many rows do we have? How many columns do we have? 1 times 2, you get? So good. So take out your chi-square table. Now the same sitting. Can you look at the last table? The last table we have is chi-square. Chi-square. Hoping we are there. Now our degrees of freedom is 2. And we are testing at 5%. So for 5%, look at where we have 0.05. Then where the degrees of freedom is 2. We are using the chi-square table. What do you get? 5.99. So this is 5.99, 5.99. This is plus and this is minus. Now our chi-square calculated is 3.3. Critical is 9.99. Accept, reject. Yeah, you accept the null hypothesis. Good. And that's how you're supposed to solve that. Now, for practice purposes, you can go and try this question. Handout. Question 1, page 12. Handout question 1, page 12. It's a question on chi-square. So, and that marks the end of that topic on the chi-square. I mean of hypothesis testing.